7, we're going to start talking about polynomials. So first we need some vocabulary. We need to know what these words mean. A monomial, so mono indicates one. So an expression, one expression that is a number, a variable, what's a variable? A letter, or a combination of a number and variables. So in the Venn diagram above, you can tell this is a monomial. It's a number 5, letters and exponent all squished together, meaning imaginary multiply. Then poly usually means many. So a polynomial is an expression consisting of one or more monomials, and each monomial is called a term. The terms are separated by plus and minus. That's how you know what starts one and stops another, how to separate them. So right here in this polynomial, you can see that you've got 1 with a plus sign, 2 minus 3 plus 4. You have 4 terms because you can tell because the terms are separated by plus and minus. Bi means 2, so a binomial is a polynomial with 2 terms. Tri means 3. It's 3 terms. In Algebra 1, that's all we usually distinguish by, and the rest of them we call polynomials. The degree is the highest power of a term in the polynomial. So if we go up here and look, then this one is a degree 2 because the 2 is the highest exponent. This one's degree 6 because 6 is the highest exponent. This is degree 4 because 4 is the highest exponent. This is the most important thing, is to know what like terms. Like terms are monomials that contain exactly the same variables raised to exactly the same exponents. And it's important to know what like terms are because you can only add and subtract them, the terms, if they are alike. You can multiply and divide anything, whether they're alike or not. You can only add and subtract the ones that are alike, and we'll do examples in a second. Standard form. Standard form is when the terms are written in descending order of the exponents. So you would start with the highest exponent, then go to the next highest, then the next. So if we were to write this in standard form, the highest exponent is the 5, so we'd write negative 7x to the 5th first. Then we have a 2 plus 4x to the 2nd. Then we have just an x to the 1, and then we have our constant, which if it kind of has an imaginary x to the 0, even though we don't need it there. That's standard form. So if we look at an example here, since the terms are separated by pluses and minuses, we have 1, 2, 3, 4 terms. Degree 4, because the highest exponent is 4, that's its degree. It's a polynomial. It has 4 terms. Sometimes you'll hear it called quartic, like quarter for 4, but in Algebra 1 you're not usually going to see those. Leading coefficient is the coefficient of the highest exponent, so written in standard form it would come first, and then the constant is the number with no variables, the negative 2. It's important to know this is 1, 2, 3. It is a trinomial. And this one is 1, 2, is a binomial. So if we're going to combine like terms, like on this one, I want an expression that would just be a term with no equal sign to represent perimeter. Perimeter is when you add all the sides. So I could start in any order with any side, and I'm going to add all the sides. I'm just going around this pentagon and writing down as an addition problem all the sides. Now I can only simplify or combine the ones that are alike. So I have some, let's start with the highest exponent. I've got some x squareds. 9 plus 4 is 13, plus 2 is 15. So I have 15 of the x squareds. Then I have x's, 5 and 1 and minus 3. So I have 3 x's. And then I have my constants. I have a -6 and a +7. So this is the simplest expression we can get, that simplest form, standard form also, that represents the perimeter of this pentagon. Now, when it's written out like this, you've got a couple of strategies here. You can just combine your like terms. And get this. But if you prefer what we call a vertical strategy, you stack them. You put the like terms underneath, just like you vertically added starting in like 3rd or 4th grade. You can treat it as a vertical addition problem. If you'd rather line them up, that helps your brain to see it better and you like that better, then you would just add straight down. All right, we've got one more that I'm going to show you here. It's a minus. So there's a couple of ways to look at this. You're subtracting. If you wanted to do it vertically, you're going to subtract this. So it's minus 10x, and then it's minus a -6 becomes plus 6, because minus negative, double negative always becomes plus. But another way you can look at it, the way I usually do it, is this is like an imaginary -1 that you're distributing. So bring down the first and distribute the -1. -1 times 10x turns it to a -10x. -1 times -6 turns it to a +6. Now I combine like terms and I get the same answer. It's just a different strategy, a different way of doing it.